In that case, we have what? We have a mean of 2.86, standard deviation 78. So let's go to 286, 2.86. And you go to standard deviation equal to 0.78, 8. The n is equal to 15, right? And the level is we're looking for is 90, so I leave it that way. And then we compute that one, and the close one is going to be 2.5, 5.1 maybe, 3.2. So A is a good one to go with this one. So that should be an answer, right? So, or you compute this one, add it to this, and subtract this, you're going to have the same result. So the key here is to know when to apply T or when to apply Z. Number 13 is the standard IQ test. As a mean 101, standard deviation 16, we want to be 98 certain that we are within 4 IQ points of the true mean. Determine requirement sample size. Well, here it is again, it's formula for sample size. But now, because we're dealing with mu, so for sample size, when mu is equal to Z, that one error, and everything is squared. If you don't remember, you can do this from, this formula here, because actually, is so you can work now this one is equal to the error, so the error divided by E is equal to this one, the square both sides, so N is equal to C sigma E squared. Well, that's the formula. So we need to know the Z value, and the Z value depends on the standard, the kind of interval we want to do. 98%, 98, we already know is equal to 2.33. So that's why the table is very good, because now you know 3. The standard deviation we want to use is the value given by standard deviation. That is 16, right? Standard deviation is 16. 16. And you need to divide it by an error of 4 points. So you divide it by 4. And that's it. So that should be the sample size. So we multiply those two divided by, and then you see that is like 2.33 multiplied by 4. So 12, 13, 9.32. We're talking about 10 actually. So 10 should be the answer. All right. So remember, the formulas for samples, determine the sample size. This is very important too. That is, those two, skip the last one because that one is using, well, if you have time, I'll do it, no problem. Number 14, a manufacturer received an order to buy bulbs. The order required that the bulb has to be life of 500 hours. The manufacturer selected random sample 25. And finally, there are mean life 495. That's the mean. Standard deviation 15 hours. Test to see if the manufacturer is making an acceptable light bulb using 95 confidence level, assuming they are normally distributed. So suppose he asked for 500 hours. So let's see if that is possible. Okay, let's determine what is the possible time that any particular, sample give that information. So let's see what we got. We got a sample of 25, okay, N is 25. And the mean and the standard deviation are given here, right? The mean is what? The mean is life is 495 hours. That he asking for 500 actually, right? That is the question, and that's for 500 hours. The standard deviation is 15 hours. Okay, that is standard deviation from the sample. So we need to test that particular claim. Okay, let's see. So we want to do a confidence interval level 95. Assuming that is 5, so it's 1 minus alpha is 95. That means alpha is what? Alpha half is equal to 0.025. Or we know that z value is going to be equal to what? 95 is 1.96. So we have all the information. We can create we can do this using our calculator, right? So let's save time and formulas to do it, because the error in this case is we want to use this formula here, where the error is equal to z alpha half is sigma, 15 divided by 95, square root of 95. We want to do this. Well, actually, let me just put more precisely here. That should be a t-value. That should be a t-value. So that one doesn't work. That should be a t-value. So the t-value is going to be different. T-value at 24 and 0.05, 0.025. And a t-value, well, let's just do this one. Okay, so that one is something that we can compute and from the table. And let me use the calculator first, just to do the one here. And if we go to the calculator and we do this and our t-test or t-interval, we use the t-interval and we need to enter the mean. The mean was what? The mean was 495 hours. We enter the standard deviation as 15. The level is 98, right? 95. 98. Yeah, it was 98, asking for. So we need to write 98 here. And we need to calculate this one. And that is the interval between 484 hours and 505 hours. And that is the test that is, well, we don't have a choice, multiple choice here, but the test, they may be as true because 500 hours is, so the test should be, we can accept, the claim, the particular manufacturer, because that could be between 400 and, what is it? That could be between 484 and 405, 505. So 500 is in between. That means that's okay. And the last one is something related to what? Okay, so that is proportion. We need some proportion. You think you can do it, right? Try to just do it. If you have any questions, let me know. And forget about this one, because that one needs a. Okay, give that to her, and see you next week. Have a nice weekend. Don't drink and drive. I'll see you later.